Welcome to Learn Yourself. Today we are going to study about light, reflection and refraction. This chapter is under CBSE Standard 10 syllabus. So in this chapter we are going to study the behavior pattern of light and how the light will bend in refraction and how it will reflect when we are putting in front of the light, the mirrors, the spherical mirrors, concave mirror and convex mirrors. So in detail we are going to study about the nature of the light. So let us start this chapter with the diffraction. So what is a diffraction? So diffraction, if an object on the path of a light becomes very small. If it will become very small, then light has a tendency to bend around it and not walk in a straight line. This effect is known as a diffraction of the light. We know that light travels in a straight line. But the diffraction is a phenomena which tells us something different. That it says that if opaque object is a kind of a translucent object, not completely transparent, not completely intransparent. So if the very small opaque object comes in a path of a light, then light will bend and pass from that. So this behavioral pattern was very difficult to understand in the beginning of 20th century. So scientists were in a dilemma that what will be the nature of the light, because at that time they were believing that light will move in a straight line, but they were not being able to understand the diffraction phenomena of the light. So once the quantum theory came into existence, they got to know about the wave nature of the light, and then all the laws came into the picture, that reflection of the light, refraction of the light, diversion of the light and many more laws. So one by one we are going to study all this law, and in that we have to study the nature of the light with the help of spherical mirrors, concave mirror, convex mirror and some of the lenses. So let us start our chapter with a simple reflection laws. Now let us understand the reflection laws. So what are the reflection laws? That when any plane mirror will reflect any ray of the light, then how it will reflect and based on what all laws it will reflect that beam, and how will be the image out of that reflection. So first law is angle of incidence is equal to the angle of reflection. Now first of all, how can we see any object? For example, this is an object and we are seeing this object. Then all the lights will fall on this object and in turn this object will reflect those rays back. Those reflected rays will come to our eye and then we will be able to see the object. At first we will not be able to see the object. That is how the reflection will work, and we will be able to see any object. That first rays of light will fall on that particular object and that object will reflect those rays back, and those reflected rays will come into our eye and we will be able to visualize that object. So that is how it will work. Now here we are talking about two rays, that angle of incidence and angle of reflection. So what is the meaning of this? So angle of incidence is the angle which is formed via incident ray. Incident ray is, for example, this is an object, so ray which will fall on the object, that is known as incident ray. And the way it is falling on the object, it will make one angle over here. It will make one angle over here. This angle is known as angle of incidence. Angle of incidence. So this we are denoting with small I. The incident ray. What is the incident ray? The ray which is falling on the object. So that ray is known as incident ray. Now that ray is falling on the object with certain angle. So that angle is known as angle of incidence. Now in turn, this object will reflect this ray back. Reflect this ray back. So this will also form one angle. This will also form one angle. So that angle is known as angle of reflection. So this is angle of incidence and this is angle of reflection. This is reflected ray. this is reflected ray. This is incidence ray, this is reflected ray. So both the angles will be equal. Both the angles will be equal. So angle of incidence is equal to angle of reflection. The way in which the angle of incidence will form, similarly the angle of reflection will also be formed. Then second, the incident ray, the normal to the mirror. What is the normal to the mirror? A perpendicular line to the mirror. If we are taking this reflected surface as a mirror, like this, then a normal to a mirror. Normal to a mirror means normal is the perpendicular line to any given object. Normal is a perpendicular line to any given object. So this is a mirror, vertical mirror, then this will be the perpendicular line to that, and this is known as a normal to mirror. This is known as normal to mirror. So incident ray, the ray which will fall on the mirror, that incident ray, then normal to the mirror, then the reflected ray. So the reflected ray back, this is reflected ray. All lie in a same plane. So all lie in a same plane. If we are talking about 2 dimension, 3 dimension, then this will happen in one single plane. Everything happens in one plane only. So these are 2 important laws when light is being reflected back via mirror, via plane mirror. This will happen. This law is applicable to all the reflecting surfaces. Now these laws are not only applicable to mirrors, but these laws are applicable to all the reflected surfaces. The surfaces which will be able to reflect the rays back. So all those surfaces will follow this reflection laws. Image formed by plane mirror is always. Now here we are talking about plane mirror. The mirror which we are using at our home. So how will be the image formation via those mirrors? So it will be virtual, it will be erect, it will be same size as object, and image will be far behind the mirror. Image will be far behind the mirror. So these are the characteristic property, and these are the properties, or this kind of image we will get it from the plane mirror. Along with the plane mirror which we are using at our home, we are going to study the curved mirror also. Now what all are this curved mirror? So curved mirror has a curved surface. Curved mirrors are commonly a spherical mirror. Why it is a spherical mirror? Because a reflecting surface will be a part of surface of the sphere. What is a sphere? If this is a sphere, then we are taking a one part of this spherical surface and we will make a mirror. If this is a sphere, then we are taking a one part of that sphere and we will polish either side, either towards this side or towards this side. It is depending upon which kind of mirror you want. If you are polishing towards this side, the side which is bulged out, that side you will polish, then it will become concave mirror, because light will fall on this and reflected from this. So this will become a concave mirror. If you will polish towards this side, what is the meaning of polish? When a polishing will happen towards the one side of the mirror, then it will be able to reflect. Otherwise it will be a simple glass, transparent glass. So any kind of silver lining we are putting on one side, only one side. If we are putting the side which is bulging out, so if towards that side we will put the polish, then this side will be used as a mirror. This side will be used as a mirror. So that is a concave lens. If the inside surface which is bulging in, that side we will put a polish, then this surface we will use as a mirror. Then that will be convex mirror. That will be convex mirror. So what is a spherical mirror? So spherical mirror is a part of sphere which we are using as mirror, and that is a part of surface of the sphere. Mirrors whose reflecting surface are spherical are called spherical mirror. Their reflecting surface are Either they are bulging out or they are going in or they are just curving inside like this, right? So either case they are a spherical mirror, but their names are different. If we will understand this with the help of a simple spoon, then this spoon will make us understand that how will be the reflecting surface. If we are talking about this surface, this curvy surface, then this will make a concave mirror. Similarly like this. So here the rays are falling on this and reflecting back. So this surface is a concave mirror. But if this side we are using as a mirror, then this will be a convex mirror, because here the rays are coming and reflecting back. So this is bulging out, whereas this is curved in, right? This is curved in. So this is, we can say that this is a concave mirror and this is a convex mirror. So you have to remember the names, that when we will say a concave mirror and when we will say a convex mirror. So if it is bulging out towards outside and this surface we are using for the reflection, then it is convex mirror. And when we are using the inside surface, then it is known as concave mirror. And both are known as spherical mirror. So here, in the case of spherical mirror, the first is concave mirror. So let us understand first what is a concave mirror and from which part of the sphere we are making the concave mirror. So this is the definition of concave mirror, that a spherical mirror whose reflecting surface is curved inward. So this is a concave mirror and its reflecting surface. This is a reflecting surface where the rays, incident rays are falling and the rays going back, those are reflected rays. So from here only the rays are reflecting back. So this surface is a mirror and it is known as concave mirror, and that surface is curved inside. So this surface is concave mirror. That is, faces towards the center of the sphere. Now what they are saying is, if this is we are taking as a spherical mirror, if this piece we are taking as a spherical mirror, then the surface which we are using should be towards the center of the sphere. If this is the center of the sphere, then this surface we should use as a spherical mirror and we have to polish the other side. We have to polish the other side, and this surface we should use as a reflecting surface to form images. So this surface should be towards the center of the sphere. Then this is known as concave mirror. Then this is known as concave mirror. A spherical mirror whose reflecting surface is curved inward, whose reflecting surface is curved inward. So this is curving inside. This is curving inside. Now, curved inward, that is faces towards. Now this is faces towards. So when we are talking about sphere, so this should face towards the center of the sphere. This should face towards the center of the sphere. At that time, this mirror is known as concave mirror. So the surface which will bend inward, and when we are putting that into a sphere, that bending surface should face the center of the sphere. So that mirror is known as concave mirror. Now what is the definition of convex mirror? So a spherical mirror whose reflecting surface is curved outward is known as convex mirror. So this mirror is convex mirror. So this surface we are using for the reflection of the image, right? These are the incident ray and these are the reflected rays. So this surface we are using, which surface is curved outward. So then it is known as convex mirror. So if in the sphere we are talking about, so this is the center of the sphere. Inside this piece we are taking as a spherical mirror and we are polishing towards this side, then this will be concave mirror whose face is towards the center. But now if we are talking the same piece we are taking and inside surface we will polish. Inside surface we will polish and this surface we will use as a reflecting surface. Inside the center is there, but this surface we will use. Then this is known as convex mirror and this is known as concave mirror. So that is only the difference between two mirrors. And this is the definition of convex mirror, that whose bending surface is bending outward. outward bending mirror is convex mirror and inward bending mirror is concave mirror. Now we will understand some of the important terms of spherical mirror. These terms we need to understand and we need to remember, because whenever we are giving a reference of all these terms and we are saying that the image formation will happen over here or here, then at that time it should click on your mind that what will be the place of the image formation or what will be the place of reflected rays. So these terms we are going to use in future. So we need to understand it and we need to remember it. So first thing is, this is a concave mirror, this is a convex mirror. Since they are spherical mirror, they are part of the sphere. They are part of the sphere. Here, till here the mirror is there and the convex mirror is here. So this surface is a reflecting surface. This surface is a reflecting surface for convex mirror and this surface is a reflecting surface for concave mirror. So concave mirror is curved inward and here convex mirror is curved outward. Outside the curved surface is there for convex mirror. So first thing is pole. Center of the reflecting surface. Reflecting surface means here this is a reflecting surface. Here inside this surface is a reflecting surface. So that center of the reflecting surface of a spherical mirror is a point called pole. So this is a surface and on that the center is there. So that is known as pole and we are denoting it with P. Here also the center of this spherical mirror is P and it is a point and that is lying on the spherical mirror. So the center of the spherical mirror is pole here and it is just a point. Now center of the curvature. Sphere has a center. Now this mirrors, spherical mirrors are a part of sphere. So if we are imagine this full as a sphere, then the sphere has a center. So that center is known as center of the curvature. Sphere has a center. This center is known as center of the curvature of spherical mirror. So this is, yes, it is a center of the sphere, but it is an important term and this term we are going to use. This center of the curvature of the sphere we are going to use when the image formation we are learning. So this term we are going to use in future. So yes, this is a part of a sphere, but even though it is taking part in reflecting of the rays when we are using this spherical mirror surface. So here this is a pole and it is a midpoint. It is a midpoint of spherical mirror and it is lying on the spherical mirror. Where is C? C is the center of the sphere. And it is known as center of the curvature of the spherical mirror. Now the important point here is in the concave mirror we are using this surface. So the center of the curvature is just before the mirror. Whereas here in the convex mirror, center of the curvature will lie behind the mirror. Because here we have selected this portion of the sphere and here we have selected this portion of the mirror. So center of the curvature will lie behind in convex mirror and in concave mirror the center of the curvature will lie before the spherical mirror. So that is the basic difference between convex mirror and concave mirror. Now we are talking about radius of the curvature. So what is the radius of the curvature? Radius of the curvature is the radius of the sphere from where? From where the sphere has made a part from the mirror. From where sphere has made part from the mirror. So from there till the center. This is a radius of the curvature. So from here we have taken the mirror. This much part or this much portion is for mirror. So sphere has made a part from mirror. So from there till the center. This is known as radius of the curvature. that is known as radius of the curvature, and that we are denoting with capital R. That we are denoting with capital R. Now one more thing is principal axis. So the line which is normal to the mirror, the line which is normal to mirror. Now what is a normal? Normal is perpendicular line to any particular object. Our object is spherical mirror, either concave or convex. So perpendicular line which is passing from C and P, and it is normal to the mirror. That line is known as principal axis. That line is known as principal axis. This is principal axis, and this is also principal axis. But again, in convex mirror, as the C is lying behind the mirror, the principal axis is also passing from the C and it will go behind the mirror. Here it is just before the mirror. Here it is just before the mirror. So what is the principal axis? Principal axis is a normal to our mirror, and it will pass from center of the curvature and the pole. Now we will see two different cases for concave mirror and convex mirror, and we will try to understand that when the rays will fall on this mirror, then which kind of image they will give us. So here we are discussing two different cases, that when we are placing an object at infinity in front of concave mirror, and when we are placing object at infinity in front of convex mirror, and the parallel rays are falling on these two mirrors, then which kind of interaction or which kind of rays we will see as a reflected rays. So here in case of concave mirror, when object we are placing at infinity, all these parallel rays, this dark line, are the incident rays. Incident rays means they are falling on the concave mirror, and this is a reflecting surface. So from there they will reflect back. They will reflect back and they will intersect with each other at one particular point. That point is lying in between C and P. Now what is the C? C is a center of the curvature of spherical mirror. This mirror is a part of a sphere that we have seen earlier, and this is a center of the curvature. Now P is a midpoint of our spherical mirror. So this F point is lie in between C and P and on the principal axis. It is all the three are lying on the principal axis. So F point is in between C and P, and what is this F? Is a principal focus of concave mirror. It is a principal focus of concave mirror, and that we are denoting with F. So when we are placing an object at infinity and those parallel rays are striking on the concave mirror, they will reflect back and intersecting with each other at one particular point on principal axis. That point is known as principal focus of concave mirror. That point is known as principal focus of concave mirror. Similarly, in the case of convex mirror, when object we are placing at the infinity and all the parallel rays are falling on the convex mirror's reflecting surface, then those rays will diverge in another direction. Those rays will diverge in another direction. But when we will extend this rays, those rays will go behind the mirror and they will intersect at one particular point. So that point is known as principal focus of convex mirror. Now this point is also lying between P and C. Since this is a convex mirror, center of the curvature will lie behind the mirror. Center of the curvature will lie behind the mirror. So similarly, principal focus of convex mirror will also lie behind the mirror, and this F point will lie in between P and C. And all these three are on principal axis. But since this is a convex mirror, and sphere will start from here, so C and F will lie behind the mirror. Here this surface is our mirror. So both of these things will lie behind the mirror. And we cannot see that these rays are actually intersecting. But when we will extend them, When we will extend them, they will go further till behind the mirror and they will intersecting at each other just like this. Behind the mirror they will intersect and they will give us one point in between P and C, and that is known as principal focus of convex mirror. Now two important terms we are discussing, that is aperture and focal length. So what is the aperture? Aperture is the diameter of reflecting surface of the spherical mirror is called its aperture. For example, this is a concave mirror. So this is M and N. So this is known as aperture. This complete is known as aperture. And what is that? That is the diameter of the reflecting surface. Reflecting surface diameter is known as its aperture. But in this chapter, in this standard, we are studying only those spherical mirror whose aperture is much smaller than its radius of curvature. Now what is the radius of the curvature? Here we have seen earlier that this spherical mirror is a part of sphere. Now from where the sphere is parting from its base from the spherical mirror, from there till the center is the radius of the curvature. So how much is the radius of the curvature? This aperture is very small compared to this radius of the curvature. So we are talking only those kind of spherical mirror whose aperture is very small compared to the radius of the curvature. Now for those mirrors whose radius of the curvature is much larger than the aperture, for them radius of the curvature equals to 2 into small f. Now what is the small f? It is a focal length. It is a focal length. This is an aperture of concave mirror. We have seen earlier that this is a principal axis, where here P is line. When the rays are falling parallel to the principal axis on this concave mirror, they will reflect back. They will reflect back and they will interact and they will intersect with each other at one particular point, that is known as F. And here is the C. F is in between C and P. F is in between C and P. So the length between P and F. F is the principal focus of concave mirror and this is a pole. Pole is a midpoint of spherical mirror. So in between F and P, this length is known as focal length. This length is known as focal length. So distance between P and F is known as focal length. So the focal length is the distance between the midpoint of the spherical mirror P pole and principal focus of concave mirror. So in between whatever length is there is known as focal length. And what is the aperture? Aperture is this complete length of our mirror. Either it is a concave mirror or convex mirror. The aperture is the diameter of reflecting surface of the spherical mirror. Image formation by concave mirror. This topic is under CBSE standard 10 syllabus from the chapter Light, Reflection and Refraction. Earlier we have seen the difference between concave mirror, convex mirror and the reflection laws. All the videos you can check on my website, as well as I have given the link of all the videos in the description. So here our topic is image formation by concave mirror. So in this topic we will place object at different position and we will see that where we will get the image, what will be the size of image and what will be the nature of the image. So these three criteria we will check for each and every position. So first position is when we will keep the object at infinity. So here A and B is object and that we have kept at infinity. So from there all the rays, all the parallel rays are striking on the concave mirror and they are reflecting back. They are reflecting back. These mirrors are the reflection. So they are reflecting back and they are passing from the point F. Now what is point F? Point F is a focus point of concave mirror. So they are passing from the F. So we will get image at F. We will get image at F. Now what will be the size of image? the image will be highly diminished and point size. Then what will be the nature of the image? It will be real and inverted. It will be a point size image, so we cannot see it thoroughly or clearly, and it will be highly diminished. Then the image will be real and inverted. Inverted means upside down. So that is how the size of image and nature of the image will be when we are placing the object at infinity. At that time we will get the image at point F. Second position is beyond C. Not at infinity but beyond C. So when we are keeping the object beyond C, then these two rays are incident rays. That one ray is going towards this concave mirror over here at the edge, and another ray, incident ray, is going towards this edge. So they are reflecting from here. So these are the reflecting rays, and this ray, while it is going towards this edge, it is passing from the C. So earlier we have seen that wherever the incident ray is passing from the center of the curvature of the spherical mirror, at that time the path will remain same for incident ray and reflected ray. So the incident ray which is going and striking over here, it will come back along the same path. It will come back along the same path, and again it will pass from the C. While it is passing from the C, this two ray will cross over here. This two ray will cross over here and here. In between this gap, we will get the image B dash and A dash. It is upside down, and the position of the image is in between C, center of the curvature, and focus point of the concave mirror. So what has happened, that when we are keeping object beyond C, so at that time we will get image in between center of curvature and focus point, and image will be diminished, real and inverted. So what will be the size of the image? It will be diminished, and nature of the image will be real and inverted. So that is how the two cases we have discussed, that when we are keeping the object at infinity and when we are keeping the object at beyond C. Third position for the object is at the C. So when we are keeping our object at C, at that time the image also we will get at the C. So this is our object, AB is an object, whereas B dash and A dash is our image. So this AB is our object, so that we have placed at C. So from here the ray will go, it will strike on the concave mirror and it will reflect it back over here. Another ray will go from here, it will strike on another extreme on the concave mirror, and then it will come back and it will cross the earlier reflected ray over here. So here all the rays are intersecting with each other. So here we will get our image. So when we are keeping the object at C point, at that time we will get image also at C point, but it will be inverted. It will be upside down. So that's why I have written here AB, but AB is an object, but the down I have written here B dash and A dash. That means this image is upside down and this is an image, and at the same point we are getting the image also. Now while these rays are reflecting and they are crossing each other, while doing so they are passing from the point F. They are passing from the point F. Now what will be the size of image? They both will be same. It will be same size as object. The size of object and size of the image will be same in this when we are keeping the object at point C. Then what will be the nature of the image? Then it will be real and inverted. It will be real and inverted. Then the next is between C and F. So slowly we are going towards the P point. Earlier we have seen that when we are keeping our object at infinity. At infinity we are keeping the object. Then we have seen beyond C. Then we have kept object beyond C. Then in the third case we have kept object at C. We have kept object at C. And in the fourth possibility, we are keeping the object in between C and F. So here we are keeping the object in between C and F. So where we will get the image? So beyond C we will get the image. That if we are keeping object here, this is our object, in between C and F we are keeping an object, then we will get image beyond C, towards this side. Towards left hand side we will get the image, and it will be inverted. It will be inverted and it will be enlarged. So the size of the image will be bigger compared to our object. So the ray which is going from the image, it will strike and it will come back and they all will intersect over here beyond C. So this image we will get beyond C and the size of the image will be bigger than the object. Fifth position for the object is at F. F is a focus point of concave mirror. So at F, when we are keeping our object, then we will get image at infinity. And image will be highly enlarged and the nature of the image will be real and inverted. So here at C point, we can see till C point, and till that point all the rays we are getting will be parallel. Once the rays are going and striking over the concave mirror and those rays are coming back, and those two rays will be parallel to each other. So they will go till the infinity and there we will get the image. The last position is between P and F. Here in between P and F, here when we are keeping our object, then image we will get is at behind the mirror. So when we are keeping our object here, this is F point and this is P point. So in between P and F, when we are keeping our object, we will get image behind the mirror and image will be enlarged. So size of the image will be bigger than the object and the image will be virtual and erect. So here when we are keeping it, the rays will go from here and it is coming back reflected. Here also one reflected ray we can see, but when we are extending those rays beyond mirror, when we are extending this rays behind the mirror, then we are getting the intersection of those rays and at that point we will get our image. So when we are keeping between P and F, we will get the image behind the mirror. It will be enlarged, virtual and erect. We will discuss the image formation by convex mirror. Earlier we have seen image formation by concave mirror and we have seen 6 different positions for image formation by concave mirror. Here we are checking 2 possibilities and here we are checking 2 positions, 2 different positions for convex mirror. So the first position is at infinity. We know that this is a convex mirror and here first what is coming is pole P, because focus point F and center of the curvature is lying behind the mirror, because this is the striking surface, and since this F and C is a part of the sphere, they will be behind the mirror. So here when we are keeping the object at infinity, here A and B is our object, when we are keeping at infinity, this parallel rays will strike on the convex mirror and they are reflecting back. They are reflecting back and they are diverging from the point F. But when this reflected rays we will extend it further. We will extend it further, they will cross and intersect at one point behind the mirror. That point is our F. So they are intersecting at point F and we are getting the image at point F. But this point F is lying behind the mirror. So what will be the size of image? That will be highly diminished and nature of the image will be virtual and erect. Then the second position is between infinity and pole P of the mirror. Here infinity is there and here pole P is there. So first point which is coming for convex mirror is pole P. So here in between infinity and pole P we are keeping our object. So here we have kept our object and we will get image between P and F behind the mirror. So in between somewhere P and F, and we will get that image. An image will be diminished, virtual and erect. So small size image we will get here, and that will be lying behind the mirror. And what will be the position? Position will be in between P and F. So these are the two cases for convex mirror. So total 8 cases we have seen for concave mirror and convex mirror, that when we are changing the position of the object, similarly we will get a different kinds of image. Hope this explanation will help you in understand the image formation via convex mirror and concave mirror. Ray diagram in case of convex mirror and concave mirror, and we will see that if different incident rays are falling on the mirror, then what will be the direction of the reflected rays. This topic is under CBSE Standard 10 syllabus from the chapter Light, Reflection and Refraction. So here, first thing is the first case when the incident ray means when the rays are falling on the mirror. Those rays are known as incident rays. So when incident ray is parallel to principal axis, that is how we will choose the incident ray. When it is falling on the mirror, it will be parallel to the principal axis. It will be parallel to the principal axis. Then where the reflected ray will go. So there are two different cases for two different mirror. This is we are discussing for concave mirror. So in the case of concave mirror, when parallel incident ray will fall on the reflecting surface, it will pass from F, and F is a principal focus point of concave mirror. So it will pass from F. So when parallel ray will fall on concave mirror, it will pass from principal focus of concave mirror. Second case, when parallel ray parallel to the principal axis will fall on convex mirror's reflecting surface, then it is appeared that it will diverge from the focus point. It will diverge from the focus point. That means this focus point is behind the mirror. This focus point is behind the mirror, but reflected ray will diverge somewhere else. It will diverge somewhere else. But if this reflected rays angle, if this reflected rays we will extend it further behind the mirror, then we can see that it is coinciding with the point F. It is coinciding with point F. So this is a reflected ray, and that if we are extending it further behind the mirror, then it will touch the point F. This point F is principal focus of convex mirror. So when on both the mirrors a parallel rays will fall on them, rays parallel to principal axis, those kind of rays will fall on the mirror, then in case of concave mirror it will pass from the principal focus point, and in terms of convex mirror it will diverge somewhere else. It will diverge away from the principal focus of convex mirror. Second case in which the incident ray will pass from the principal focus point. So first case is for the concave mirror and second case is for the convex mirror. So here when incident ray is passing from the principal focus of concave mirror. So here this is our concave mirror, this is aperture M and N, this is our principal axis, and the incident ray, this is incident ray and it is passing from the point F. Then the reflected ray will emerge as parallel to principal axis. So reflected ray will be parallel to principal axis. We can see that this ray is parallel. So the ray, only one ray we will get it like that, that ray will pass from F and it will emerge as parallel to principal axis. That will happen in case of concave mirror. Now the second case is when incident ray is directed towards the F. Now here in case of convex mirror, point F and point C, the principal focus point and center of the curvature, both lie behind the mirror. So we cannot pass our incident ray from the F. So here we are directing our incident ray, towards the F, such that if we will extend it further behind the mirror, it will connect to, or it will pass from the F. That is how we will make this ray fall on the mirror. So the emergent ray or the reflected ray, what will comes back from the mirror, will be parallel to principal axis. So in both the case, when the incident ray will pass from principal focus point of concave mirror or convex mirror, they will emerge as parallel to principal axis. Here we can pass from the point F because it is front of the mirror, but here we will make a ray fall such that it will direct it towards the F. So if we will extend it further behind the mirror, it will touch the point F, or it will cross, or it will pass from the point F. In that case, that ray will reflect it back and it will emerge as parallel to principal axis. In the third case, when the incident ray is passing from the center of the curvature C. So in the case of concave mirror, when incident ray is passing from the center of the curvature C, that ray will strike on the reflecting surface of concave mirror and it will move back along the same path. So incident ray and reflected ray, both rays path will be same when the incident ray is passing from the center of the curvature C. So that will happen in case of concave mirror. Now in case of convex mirror, so since this F and C both are lying behind the mirror, we can only divert this ray towards the C. We cannot pass it from the C. So we can write here that when incident ray we are diverting towards the C. In earlier second case also we have seen that when incident ray we are diverting towards F and it will divert away from the F. That is how we will write when we are talking about convex mirror, because they are lying behind the mirror. So we cannot pass actually the rays from that. So here when the incident ray we are diverting towards the C, so that its ray is such that if we are extending that ray, then it will pass from the C. So when the incident ray we are diverting towards C, it will comes back along the same path. So here also incident ray and reflected rays path will be same. So in both the case, when the incident ray will pass from center of the curvature C, then the ray will comes back along the same path. Fourth case, in which the incident ray is obliquely to the principal axis and it is towards the P. So now what is the meaning of obliquely to principal axis? That slanting towards the principal axis. When the incident ray, this is incident ray, when it comes slanting towards the pole P, then it will go also obliquely. Then the reflected ray also we will get obliquely to the principal axis with respect to principal axis. So if it is coming slanting, and it will go also with the same angle in another direction obliquely. So however it is coming the same way, it will go back when it is coming obliquely and it is towards the pole P. At that case, in concave mirror, reflected ray we will get obliquely. Now in case of convex mirror, when the slanting ray is coming towards the pole P, we will get the obliquely reflected ray, because here this P is lying on the mirror, it is not behind the mirror. So we will get the same result in both the mirrors. In terms of concave mirror and convex mirror, we will get the same result, because here P is lying on the mirror and not behind the mirror. So these are the four possibilities of concave mirror and convex mirror. This first one are the concave mirror and the second one are the convex mirror. So when incident ray is parallel to principal axis, it will pass from F, that is a focus point of concave mirror and convex mirror. But here, since this F and C lie behind the mirror, we can see that they are diverging away from the F. They are diverging away from the F, and when reflected ray we will extend, it will connect to F. It will connect to F. So in both the case, the overall picture we will get is something like this. Then when incident ray is coming parallel to principal axis, it will pass from focus point of concave or convex mirror. Then in second case, when the incident ray is passing from the focus point, when incident ray is passing from the focus point here, we are diverting incident ray such that it will meet with focus point behind the mirror. Then the reflected ray will be parallel to principal axis. Reflected ray will be parallel to principal axis. So this both cases are opposite to each other. When the incident ray is parallel, it will pass from F. The reflected ray will pass from F. And when the incident ray is passing from F, then the reflected ray will be parallel to principal axis. So this both cases are opposite to each other. Then here, when incident ray is passing from center of the curvature, then it will go back along the same path. Here also, when incident ray is falling on the convex mirror such that when we will extend, it will touch the center of the curvature, then it will go back along the same path. Then when obliquely any ray will come, incident ray will come towards the pole P, then the reflected ray also we will get obliquely. So there are four cases. When incident ray will pass from F, it will emerge parallelly. When incident ray is parallel to principal axis, then it will pass from focus point. When it will pass from center of the curvature, the incident ray and reflected rays path will be same, and when any slanting ray is coming towards the P, it will go also slanting from the pole P, and it will be slanting compared to principal axis. So these are the four cases, and like this if you will remember, then it will be really easy to remember all the details. The uses of concave mirror and convex mirror. So these uses are based on their characteristic properties of how they are forming the images. So first we are going to study the uses of concave mirrors. So here first use is they are used in torches, searchlight and vehicles, headlight to get powerful beam of light. So how will be the concave mirror? Concave mirror is something like this, So we have seen this kind of headlight in our vehicle or in our two-wheelers. So this will throw a powerful beam of light, and this kind of mirror we can also see in torches. So where we require a powerful beam of light, there we are using the concave mirror. Then they are also used in shaving mirror to see the larger image of the face, because the image which we are getting from the concave mirror, they are bigger than the actual object, so that we can see a clear image of our face. So that's why we are using it into a shaving mirror also. Then so the third one is dentists use this to see large images of patient's teeth. So inside any cavity or gum growth is there, then to see that, dentists are using this kind of concave mirrors. Then large concave mirrors are used to concentrate the sunlight to produce heat in solar furnaces. Yes, it is true that when we require a large amount of solar heat, then we can use this concave mirrors, and actually we are using those into producing a heat in solar furnaces. So these are the uses of concave mirror based on its characteristic property that it will give powerful beam of light, it will give a larger image, and it will concentrate the sun rays. So these uses are based on the characteristic property of concave mirror, that how they are used, that as they are giving the powerful beam of light, so they are used in the headlights of the vehicle, they are giving us larger image, so they are used in the shaving mirror, and they will give us a concentrated beam of sun rays. So that's why they are used in solar furnaces also. We will discuss the uses of convex mirror. So convex mirrors are commonly used as rear view mirror in vehicles and all. So in the vehicles, the side mirrors which we are using to see backside view of us, that is made by convex mirror. So it will enable us to see that how many vehicles are behind us. So convex mirrors will give erect though diminished image. They have a wider field of view as they curved outward. So how will be the convex mirror? Convex mirror is something like this. So they are curved outward. So that's why it will give us a larger area of the view. They will give us wider view compared to a simple mirror. Convex mirror enables driver to view much larger area than it would have been possible with a plane mirror. So this covers larger area. So that's why we are using this in a rear view mirror. And what will be the image? The image will be erect, diminished image, but a larger area will be covered by the convex mirror, and that's why we are using it. We do not need a complete real or complete perfect image when we are checking that how many vehicles are at our back. We only need to see that even if it is a hazy image, we can judge that there are 3 or 4 vehicles behind us, but a wider field will give us better judgment. So because of this, we will use convex mirror. Here we do not need any perfection in the image. Here what we need or required is wider view. So it will enable us to judge whether we can turn from here or how much traffic is there behind our back. So this wider field of view will enable us to take the decision. Here we do not need a perfect image. This kind of image we require when we are seeing our face, and that is given by the concave mirror. Here we need larger view and not the perfect image. So we are using convex mirror. Sign convention for reflection by spherical mirror. And these rules are given by new Cartesian sign convention. So these topics are under CBSE Standard 10 syllabus from the chapter Light, Reflection and Refraction. So here this we have taken a concave mirror, and we are going to discuss with the help of this concave mirror that when we are keeping an object at certain distance, where we will get the image and what will be the nature of the image and what will be the size of the image. For this we need to understand certain rules which has been given by the new Cartesian sign convention. So we have to follow those rules, and 2 formulas. First is mirror formula and second is magnification formula. So with the help of these 2 formulas we will calculate the numerical, we will get the answer, and that answers we need to interpret as per these rules. So let us first understand this diagram. This video is only for the mirrors and this is not for the lens. So for the lens, mirror formula and magnification formula is different. Here we are talking about mirrors. So we are including here concave mirror and convex mirror. So for concave mirror, this surface is reflecting surface. The inward surface is reflecting surface. Whereas for the convex mirror, the outward surface is reflecting surface. This surface is outward surface and this is for convex mirror. This is concave mirror, and what all rules we are discussing here will be applicable to all the types of spherical mirror and specifically 2 mirrors which are in our syllabus, that is concave mirror and convex mirror. So it will be applicable to both the mirrors. So first is when we are getting image towards the left side. So this is our concave mirror and towards the left side. So this is left side and this is right side. So when you are writing in your notebook, towards your right hand side this is a right side, and towards your left hand side this is your left side. So towards the left side, when you are going towards the left side, and this is concave mirror, So towards the left side, whatever distance we will get, those all distances will carry negative sign. Now what is the meaning of distance? So distance we are measuring from the pole P. Now what is pole P? Pole P is a midpoint of spherical mirror and it will lie on the surface of the mirror. So here this is a pole P. So from pole P we are measuring a distance. That pole P where we have kept the object and where we got the image. Here AB is the object and here A dash B dash is our image. So how to measure a distance? So always we are checking the distance from pole P, that from pole P how much far it is, and whenever it is towards the left side, that distance we are denoting with negative sign. That indicates that this is towards the left hand side. And when all the distances for the object we are keeping it here, but when in the case of convex mirror, the focal point is lying behind the mirror. This is a convex mirror and focal point is lying behind the mirror. So most of the time we will get the image behind the mirror. So for that cases, whenever we are getting the image, that distance we are denoting with positive sign. That distance we are denoting with positive sign. That means image what we are getting is towards the right hand side. So this distances we are measuring from the mirror formula. Now what is the mirror formula? Mirror formula is, this mirror formula are for the mirrors. So 1 divided by V plus 1 divided by U equals to 1 divided by F. Now let us see what all these quantities are. So we suggest that distance of image from the pole P. Distance of image from the pole P. Then U is distance of object. Distance of object from the pole P. So U will tell us where we have kept the object and V will tell us where our image will be or where we will get the image. Now F is a focal length. F is a focal length. What is a focal length? So focal length is a distance between pole P and focus point. Focus point is in the front of the mirror for concave mirror and it will be behind the mirror for convex mirror. So that is focus point, and the distance between focus point and pole P is our focal length. Focal length we are getting it from the radius of curvature, that R equals to 2F is the formula. So sometimes they will give you the focal length and sometimes we have to find out from this formula that R equals to 2F. So radius of curvature they will give us, from that we can find out the focal length. Now whenever we are getting the distance of the image, if this is negative, that if it is negative, then that means that image we are getting it towards the left side. If that answer is positive, V is positive, then image we will get it towards the right hand side. From the mirror formula we will get only one thing, and that is position of the image. That is position of the image, that from the sign we will get to know that whether it is towards the left side or right side, and the number will denote the distance, that how far it is from the mirror, either it is concave mirror or convex mirror. Now we are going to discuss about magnification of the mirrors. So what is the meaning of magnification? It means the enlarging of the image. But sometimes the image are smaller compared to the object, sometimes the image are enlarged compared to the object, and sometimes the size of the image will be equal to the size of the object. So all these details we will get it from this magnification formula's answer. So the formula is minus V divided by U. So this minus sign is there into the formula. So V is distance of image from the pole P, U is distance of object from the pole P. Once we will put these two things, we will get one answer. If it is carrying negative sign, that means the image is real. If it is carrying positive sign, that means the image is virtual. So from the sign of the answer of magnification formulas calculation, it will tell us whether the image is real or virtual. Now, whatever number we will get here from this calculation, that number will tell us whether the image will be bigger, smaller or equal to the object. Sometimes magnification formula we are also calculating with respect to height of the object and height of the image. So in that case we are using h dash divided by h formula. H dash is the height of the image and h is height of the object. We can also refer it to size of the image and size of the object. Now whenever we are getting the image above the principal axis, then the sign is positive. Whenever we are getting the image inverted and below the principal axis, then the sign will be negative. So here there are four types of sign we have to understand. That if towards the left side, then it is negative. If it is towards the right hand side, then it is positive. If it is above the principal axis, then it is positive, and if it is below the principal axis, then it is negative. And everything we have to interpret, that nature of the image, position of the image and size of the image. All these things we have to interpret from our answer, that our answer carries which sign, either positive or negative, and what is the answer. So from all these things we have to interpret the answer, that whether our image is real or virtual, it will be, what will be its size, it will be enlarged or it will be point size or it will be equal to the object. All these things we have to interpret from the answer. Refraction phenomena through glass slab, and these topics are under CBSE Standard 10 syllabus from the chapter Light, Reflection and Refraction. So here, what is the meaning of refraction? So when light is traveling from one medium to another medium, its path will not be in a straight line. It will be deviated, it will be refracted. When the path of light is not a straight line and it will move away from its actual path, that is known as refraction. And this phenomena we can see when light is changing a medium. Now what is the meaning of medium? So here air is there. So air is a medium in which light shows the maximum speed, and it is almost equal to the speed in the vacuum also. So whatever speed of light is there in the vacuum, it has this almost same speed in the air also. Now whenever there are two mediums involved, that it goes from air to glass, air to water, air to oil or something like that, then its speed will change as it is entering from thinner medium to thicker medium. That we are denoting as rarer medium and denser medium. All those things we are going to discuss in detail, but here we have to make a note of that point, that when a light is passing from one medium to another medium, it is changing its path and it will deviate it. It shows the refracted phenomena, and that is known as refraction of light. Now how it is changing and why it is changing. So all those things we are going to discuss in this video. So let us first understand this activity, then we are going in a detail that what is a refraction and where we can see the refraction. So here we have taken one glass slab. This ABCD is the surface of the glass slab, and glass slab is this much thick. So when from this side one ray of light is entering, we can see from here that where it will go. So once the ray of light is entering from this surface, actually it should travel through this glass slab and it should reach here. It should reach here. But actually we are getting that light ray here. Instead of here, we are getting the light ray here. So this much is the deviation from its original path. So at the AB surface, the incident ray of light is falling here and it is striking at the surface. Now here it is passing from the glass slab here and it is coming out here. So here when it is touching the surface of the glass slab, this is our incident ray. Because what is incident ray? Incident ray is that which is falling on the surface. The ray which is coming and it is striking on the surface. So this is incident ray. Here this is our incident ray and this is our glass surface. And we have drawn one normal to that surface. Now what is the meaning of normal? This dotted line and n dash is a normal here. This n dash is a normal. Now what is a normal? Normal is a perpendicular line to any surface. When with any surface we are drawing a perpendicular line, that is known as a normal. So here with respect to this incident ray, we have drawn here a normal. Now this is air and this is glass. So light ray is coming from the air and it is going into a glass. So here it is changing a medium. Here it is changing a medium from air to glass medium it is going. Now here air is a rarer medium. Now what is the meaning of rarer medium? It is always respective. That when you are checking this two medium, then air is a thinner medium and glass is a thicker medium. That means air is a rarer medium here and glass is a denser medium here. So hope this video has cleared your doubt. In coming segment, we are going to discuss many more important concepts. So don't forget to subscribe, learn yourself. I'll see you in next video. Till then, keep learning, keep sharing.